Hey everyone, welcome back to our APIGURU channel. For those of you who are new here, I'm Damien Tone here. On this channel we share everything you need to know about APIs. Today we will explore how to develop APIs using an agile approach. Let's get started. A key aspect of agile is the formation of a cross-functional API team. The API team should operate as a largely self-sufficient unit with minimal external dependencies. Let's take a closer look at what an agile API team looks like. The core API team, which consists of the API product owner, Agile API lead, API developers and API QA engineers, is at the bottom. They all collaborate closely and continuously. In the middle are additional core team members. These individuals may not be fully dedicated to the API team but are partially allocated over time to support multiple API initiatives. Arrows illustrate connections with non-core team members, indicating specific individuals responsible for key activities. Throughout this course, we will delve deeper into each role and the relationship within the Agile API team structure. One of the biggest pitfalls for teams starting with Agile is taking on too much scope. Reducing the size of each software scope increment is a great way to adapt to changing plans. Developing software in a new way can be difficult for inexperienced teams, so a smaller scope is even more ideal for them. Size the scope of your API project right and focus on the minimum viable product. Ask your team, what is the least we need to build that will still deliver business value? The picture here shows 3 different ways to build a transport device over 4 releases, with the business goal of getting from point A to point B. The first example should be avoided, building incrementally. After each release, there is no business value since we only get from point A to B until the end of release 4. The second example is better. It achieves the goal of getting from A to B in each release with a working device, but it forces the team to rework the product in every release, leading to a lot of waste and throwaway effort. The third example is the MVP approach. We can transport from A to B in each release, but we have minimal rework since we build on the functionality of the previous release in a smart sequence. You can think of Agile API development just this way. Deliver the right MVP and pay close attention to the sequence in which you release your new APIs. Achieving efficiency is not just about releasing frequently. Releasing with quality while minimizing effort is essential. Rather than waiting until development is complete to write test cases, it's far more effective to define these tests and establish success criteria during the design phase before development begins. This proactive approach is reflected in 2 methodologies: test-driven development and behavior-driven development. Both methods are similar and aim to produce high-quality code. Both TDD and BD result in code that QA engineers can easily automate. They can create a series of unit tests and integrate them into broader integration tests for the API. By developing test cases as programmable scripts, we can execute these tests repeatedly, significantly reducing the traditional QA bottleneck and accelerating the feedback loop. Automation and quality are fundamental principles of agile transformation, and few practices exemplify this better than establishing a continuous integration and continuous deployment pipeline. The primary goal of CI/CD is to avoid integration conflicts, where multiple developers try to integrate large pieces of code late in the project, leading to chaos and delays. To prevent such issues, the cycle illustrated highlights the process from code check-in to testing, deployment of the API bundle, and updating API documentation. This cycle should be performed frequently, ideally after each code commit. Much of this process can be automated by utilizing tools like Jenkins and programming the workflow to move code through each stage. This automation reduces manual effort and increases the cycle's frequency, allowing errors to be identified and addressed early, starting from the first week of development. Here's a look at the familiar waterfall process. It features long release cycles with extended stages and significant handover points, often transitioning from one team to another. This approach carries inherent risks, as many unknowns remain hidden until we reach a specific stage. You've likely experienced this firsthand and may have some compelling stories to share about the challenges it presents. Teams transitioning away from waterfall often find themselves slipping into Scrumfall. While Scrumfall breaks work into sprints and initiates testing cycles earlier, enhancing visibility and allowing quicker pivots, it still has drawbacks. This model treats testing as a post-sprint activity rather than being integrated into the requirements definition and sprint phases. This separation can lead to elongated testing and bug-fixing timelines, resulting in longer release cycles. While this approach is an improvement over waterfall, especially when working with an enormous scope that can't be easily divided, it doesn't fully leverage the potential of agile practices. In the context of API development and most software projects, we can push beyond Scrumfall to achieve a more efficient and integrated workflow. The first crucial tactic to avoid falling into Scrumfall is integrating development and QA within the same sprint. This may require your team to take on a smaller workload to allocate sufficient time for bug fixing. However, by merging testing and debugging efforts into the sprint, you'll ensure the functionality is thoroughly tested and ready for release by the end of each cycle. This approach enhances the quality of your output and empowers your team to adapt more effectively as needed. Making this a primary goal will significantly improve your agile practice. Testing vigorously during development isn't sufficient on its own. It's essential to embed the principle of defining quality from the outset. If developers aren't fully aware of the testing criteria, or if QA engineers spend excessive time establishing these criteria during the sprint, valuable time will be lost. To maximize efficiency, encourage QA engineers and developers to collaborate on the requirements to define the testing criteria before the sprint begins. This can be achieved through methods like test-driven development or behavior-driven development, which we discussed earlier. Consider coding the test scripts in advance, allowing QA engineers to focus on minor adjustments during the sprint. Your final step is to automate the CI/CD pipeline by integrating testing definitions between the requirements and sprint phases. It's crucial not to shortcut or compromise on establishing a solid foundation for automation, testing, and optimizing your team's processes. Over time, your team will gain confidence in the system as the automation streamlines development and enhances quality. The initial investment in these practices will pay off, resulting in faster release cycles and improved overall performance. Now that we've established a high-level overview, let's delve deeper into the Agile process. Two standard methodologies are Scrum and Kanban. Scrum is structured with more defined processes and steps, making it familiar and accessible for many teams, especially those new to Agile. Its cyclical approach to development encourages collaboration and accountability. On the other hand, Kanban is straightforward and focuses on smaller, manageable, less interdependent tasks. Teams with solid self-management skills and a history of collaboration may find Kanban a better fit. This course will focus on Scrum due to its complexity and widespread adoption. Regardless of which methodology you choose, commit to it fully. Avoid switching back and forth until your team has had the opportunity to experience and learn from the process. Since the Scrum process can be complex, we'll break it down step by step. Let's start with step 1. The API product owner defines the product vision and develops an API product roadmap based on this vision. This roadmap outlines the high-level scope of the components necessary to realize that vision and deliver value to the organization. This roadmap might encompass various elements, including different sets of APIs, strategies for business adoption, app usage metrics, key compliance initiatives, infrastructure needs, and even enhancements to the developer portal. Once the product roadmap is in place, the next focus should be defining the first valuable release. Remember the minimum viable product principle to ensure you deliver maximum value with minimal effort. Let's move on to step 2. Now that we have the scope for the first release, the next step is to quickly transform it into a prioritized list of requirements. These requirements should be framed as epics and user stories. At this stage, it's common to desire to explore extensive detail. Resist that temptation and focus on capturing high-level features and requirements instead. If you spend more than a week on this task, you are likely delving too deep. Keep it concise and prioritize clarity to maintain momentum. Let's continue with step 3. This is where most of the actions and processes take place. The API team will select the most critical user stories in the upcoming sprint. Each user story must be thoroughly detailed and encompass business, technical, and testing aspects. During this phase, the API team reviews each user story, breaking it down into specific implementation tasks. They estimate the effort required for each task and commit to a set of user stories for the next sprint. Sprints typically range from 1 to 4 weeks, but many API teams find that 2 weeks strike the right balance. By the end of the sprint, the user stories should be completed and ready for deployment. Any unfinished work will be carried over to the next sprint or returned to the product backlog. This cycle then repeats, fostering continuous progress and improvement. Throughout the sprint cycle, the Scrum Master serves as the team's coach, tracking productivity through burn-down and burn-up charts that measure progress in terms of velocity. We will explore the concept of velocity in greater detail later in this course. Alongside tracking progress, several key ceremonies are integral to the Scrum framework, detailed in steps 4, 5, and 6. Let's continue with step 4. The daily Scrum is a 30-minute meeting in which each team member shares the progress, outlines the tasks, and highlights any blockers they face. This is an essential time for the team to assess the progress, drive action, and seek assistance. Let's move on to step 5. The sprint review, also known as the sprint demo, occurs at the end of the sprint. This meeting recaps what has been accomplished and provides an opportunity to celebrate and showcase the team's achievements. Finally, let's move on to step 6. The sprint retrospective also occurs at the sprint's end. In this ceremony, the team reflects on what went well and identifies areas for improvement. Often the most valuable insights and enhancements emerge from these retrospective discussions, fostering continuous growth and collaboration. Let's deeply dive into the tasks involved in transitioning from the backlog to the sprint. Taking another view of a sprint by sprint, you will see a repeating pattern where the product backlog items are refined before the start of development. This repeating effort is called backlog refinement. A team process usually established at the beginning of the project is called the definition of ready. This checklist is the agreement within the team about when a story is refined enough for the developers and QA engineers to start the sprint. As a result, there is a clear target for even the team members to refine how far they need to go to meet the definition of ready. Refinement is a collaborative activity. The product owner, API architect, and QA engineer must all focus on the same user stories in the priority order of the product backlog. After they are done with refining S1, they move on to S2 and refine that set. This continues until the backlog is all refined. Sprint planning begins once a set of user stories for Sprint 1 has been refined. This can take the form of either a series of brief recurring sessions before the sprint or a more extended meeting at the start of the sprint. The output of this planning phase is a comprehensive list of tasks per user story. With this clarity, the API team can dive into development and start writing and executing test scripts. This iterative process continues into Sprint 2, Sprint 3, and beyond. Additionally, the team must establish a definition of done for each user story at the start of the sprint. This is a benchmark for completion, and quality standards must be upheld. By clearly defining what done means, the API team can avoid misunderstandings when a user story is marked as complete at the end of the sprint. It's the collective responsibility of the team to ensure that this standard is consistently enforced. In the final step, completed work is queued for product release and bundled together for each sprint. The automated CI/CD pipeline streamlines this final stage of the process, efficiently moving tested and approved code into the main branch. Let's dive into epics and user stories. An API program often begins with a high-level scope, which is typically easier for stakeholders at all levels of the organization to understand. This scope may encompass one or more API products planned for the next release. Let's take the global rewards program as an example. To make this high-level scope actionable, it's essential to break it down into smaller, manageable pieces. The next level of detail is an epic, which can be viewed as a significant feature that aligns with the business need. Epics help organize related technical or functional elements, providing the API team with a clear reference point. For the API team, epics often represent a collection of multiple APIs or a specific API product. For instance, we might have an epic titled Rewards Points for the global rewards program that represents an API product. However, this level of detail is still insufficient for development. The API product owner will typically draft a few sentences or bullet points to define each epic. To ensure that these can be built effectively, we must break them further into more minor requirements that can be addressed in a sprint. These smaller units are called user stories. A user story represents a specific deliverable such as a single API or a particular operation, like a GET or POST request. For example, we may have one user story for the epic rewards points to get the user's current rewards point balance. Each user story must be clearly defined to guide API developers in coding and QA in testing. Once we've broken down the scope and epics into sufficient user stories, we can assign them to upcoming sprints. It's unnecessary to slice all scope and epics into user stories simultaneously. Instead, prioritize what's most important for development. A word of caution, new teams often struggle to slice their user stories into small enough units. They may find that the stories are overly complex once they begin development. Remember, smaller stories generally lead to better outcomes. Additionally, don't hesitate to split a user story into multiple stories during refinement if it is too large. Consider using user story mapping if you're looking for effective ways to break your product into smaller components. This approach can facilitate collaboration within your team. Excellent step-by-step guides and examples are available to help you start. Check the comment section links. Writing user stories can be challenging due to the varying interpretations of a single sentence. Developers, QA engineers, and product owners often have different perspectives, leading to misunderstandings. By implementing a consistent structure for user story writing, we can better articulate our needs and enhance clarity in interpretation. To achieve this, we follow a structured approach that prompts us to consider whose perspective we are adopting and what they want to achieve. It's essential to clarify why they want this, exploring their motivations, beliefs, and desired rewards. Applying this framework to user stories empowers our team to ask better questions and refine and clarify requirements more effectively. This helps ensure the why aligns with our goals, prevents unnecessary complexity, and confirms testability. Ultimately, this process fosters open dialogue and encourages a shared understanding among team members. For teams and product owners new to Agile, a straightforward way to enhance user story quality is by focusing on writing comprehensive acceptance criteria for each story. The initial one-sentence user story is often too high level, inevitably missing the finer details that developers and testers require. Often referred to as the 3Cs approach, developing acceptance criteria relies on the product owner. The process begins with the one-line user story known as the card, which is discussed with the development team. Through this conversation, questions about the user story emerge, leading the product owner to document the conditions of satisfaction that confirm the user story is complete and functioning as intended. Writing acceptance criteria can result in a detailed and sometimes complex list, depending on the intricacies of the user story. For those with software development experience, this step feels akin to outlining detailed functional requirements. It's crucial to be specific in your acceptance criteria to eliminate ambiguity. Include explicit error codes in the API, specify the conditions that trigger them, and define the exact values to be passed or returned. If there are multiple conditional flows, clearly outline the sequence involved. Additionally, you may encounter scenarios where the same acceptance criteria apply to several user stories, such as shared workflows or standard policies. In such cases, creating a separate acceptance criterion linked to each relevant user story is beneficial, ensuring clarity and consistency across the board. An advanced approach to writing acceptance criteria is behavior-driven development using the Gherkin syntax. This method employs the given when-then format, which serves the same purpose as traditional acceptance criteria, enhances clarity, and reduces the likelihood of overlooked requirements. Teams often find Gherkin more developer-friendly and conducive to test automation. In this framework, tests can be crafted collaboratively by the product owner, QA engineer, or developers right from the outset. However, it's important to note that navigating the complexities of advanced use cases can be challenging for non-technical product owners. Here you can see an example using the Gherkin format. Another significant advantage of the given when-then format is its ability to be transformed into code. The syntax can be organized into a Gherkin BDD feature file, enabling QA engineers to create automated test scripts. This approach seamlessly connects high-level user story objectives with testable and automatable scripts. Crafting a Gherkin feature file lets us capture our tests in a structured yet human-readable format. Tools like APIGURU facilitate this process by converting the written specifications directly into test script syntax, streamlining the transition from requirements to automated testing. Stepping back, the elaboration process for a user story is essential for preparing it for development. The goal is to ensure that all dependencies, requirements, technical solutions, and acceptance criteria are clearly defined and aligned with the team's definition of ready. This allows developers and QA engineers to concentrate on coding efficiently and delivering high-quality results. The API team establishes the definition of ready upfront, ensuring that everyone has a shared understanding of expectations. As illustrated, achieving readiness is not the responsibility of a single individual, it requires a collaborative team effort. To effectively meet the definition of ready, the API team involved in user story refinement typically includes several key roles. The API product owner plays a crucial role by selecting user stories from the backlog and elaborating them in detail using the Gherkin format. Given the number of user stories in a sprint, this can be a significant workload, requiring the product owner to dedicate time to critical thinking and writing. In some teams, a dedicated API architect is responsible for developing the API specification and creating sequence diagrams. In other cases, the architect may provide consultation and design guidance, while the API developers take on this responsibility. The QA engineer is tasked with preparing test scripts and may also contribute to writing Gherkin scenarios alongside the product owner. Regardless of who writes the Gherkin feature file, the QA engineer relies heavily on insights from the product owner and the architect to ensure comprehensive coverage. This collaborative triangle embodies the essence of teamwork in Agile. The three roles must work closely together, often side by side, to refine user stories effectively. Passing user stories without real-time communication can complicate the process significantly. Peer review and constructive challenge among the team members are vital to ensure that the resulting user story is well defined and thoroughly considered. We often observe quality issues and high defect rates in API projects not due to coding errors, but rather because of poorly defined user stories that lack these essential perspectives. Finally, just as the definition of ready is essential, the definition of done is equally critical for establishing a shared understanding of what constitutes complete within the team. Agile teams should come together at the start of a project or sprint to create or revise the definition of done, ensuring everyone is aligned on the goals and expectations. A clear definition of done empowers developers and test engineers by giving them a stable target for success and minimizing uncertainty in their work. Additionally, both definitions clarify responsibilities within the team, fostering accountability and collaboration. High-performing Agile teams often evolve these definitions over time, incorporating lessons learned after each sprint. Agile is a highly measurable and quantifiable development process. It allows teams to address common questions from traditional project management, such as development timeframes and scheduling, by fostering a deeper understanding of user story estimation. User stories can be estimated during roadmap planning, often using broad t-shirt sizing for initial estimates. They are then refined further during user story refinement or sprint planning. Anyone with experience in software development knows that estimation can be complex and challenging. Let's compare traditional waterfall estimation practices with Agile and Scrum ones. Pause the video to take a closer look at the differences. You'll likely notice some fundamental changes, many of which you may be relieved to leave behind as you transition away from waterfall. A common challenge for teams adopting Agile is managing expectations around timelines and schedules. Agile focuses on estimation in smaller, more manageable sessions, utilizing detailed information as it becomes available. In contrast, traditional organizations often rely on upfront funding cycles and budgets, necessitating large-scale estimations. While your team might still need to provide initial estimates, embracing Agile estimation practices can enhance your processes in the long run. Now let's discuss the units of measurement for estimation. Story points are not officially part of Scrum but align well with its principles. In this framework, the unit of measurement for a user story is user story points. Each user story is assigned a point value, which reflects its relative complexity compared to other stories. For example, a story assigned 1 point typically involves straightforward tasks, like updating a policy. In contrast, a more complex story, perhaps creating a new auth API, might be assigned 8 or 13 points. We'll explore this shortly. It's important to note that these points signify the complexity of the work rather than the actual hours or days required to complete it, which would be a unit of effort. Thus, the size of a user story becomes a crucial metric for quantifying work. For instance, if your sprint includes 5 user stories, each valued at 3 points, you will have 15 points for that sprint. While this figure may not be meaningful, tracking it over time can reveal valuable trends. When assigning story points to user stories, it's crucial to avoid equating a point with a specific unit of time. Practices like assuming 1 point equals 1 day can quickly skew perceptions of a user story's true nature. While there is some correlation, the most crucial factor is to link points to complexity and risk. This approach allows for a more objective assessment of work size, free from biases related to individual effort. For instance, a junior developer may require more time to complete a complex user story than a seasoned developer, but the inherent complexity and uncertainties remain constant. With this principle in mind, a 3-point user story might initially take a developer an entire sprint to complete. Still, they may tackle 2 3-point stories simultaneously after a few sprints. To enhance the accuracy of story point assignments, we recommend using a blind voting mechanism. In this method, each developer reviews the user story details and independently assigns a point value without discussing their thoughts with one another. Once all developers have cast their votes, they can reveal their estimates and engage in a discussion to reach a consensus on the final size of the user story. This approach helps eliminate bias and ensures the team's collective intelligence is utilized in the estimation process. The list illustrates a sample point system intentionally following the Fibonacci sequence. This approach creates larger gaps between numbers, reflecting how uncertainty increases with complexity. Before starting a project, Teams typically revise and agree on point values and their definitions. Alternatives like half points or higher numbers and example reference stories can clarify what each point value represents. Once the point system is established, it's essential to stick with it. Avoid prolonged debates or delays in finalizing the system. After a few sprints, teams may find it beneficial to reference previously delivered user stories as benchmarks. Some teams implement rules that prevent stories rated at 8 points or higher from being included in a sprint, requiring further refinement and splitting. Whether you choose 8, 5 or 13 points, the crucial factor is for the team to learn from past experiences and adopt corrective practices to enhance estimation accuracy. Ultimately, consistency in using the point system is more critical than having overly detailed definitions. Importantly, avoid directly correlating points to hours or days of effort. Many teams choose to break down the activities required to develop a user story into specific tasks during sprint planning. Each task represents a component of the user story, and a single user story can encompass multiple tasks. These tasks can include activities such as coding, configuration, code review, testing, and deployment. Each task must be tailored to the specific user story it supports. This approach helps ensure that developers and testers responsible for the user story have thoroughly considered the necessary steps for completion. Furthermore, these tasks provide a detailed framework for measuring the user story's progress. Each task should align closely with the definition of done, ensuring a clear path to completion and maintaining accountability throughout the development process. Some teams find it beneficial to include hour estimates for tasks, although this practice is optional. When many developers are working on multiple user stories simultaneously, it can be challenging to gauge daily progress accurately. Teams often engage with every story throughout the sprint, culminating in a flurry of activity as the deadline approaches. In this context, a sprint burndown chart can visually represent daily progress by showing the remaining hours from the start to the end of the sprint. This visualization helps the team see how much work is left and encourages a steady pace to stay on track. Implementing this level of metric tracking requires developers and QA engineers to update the remaining hours for each task daily. While this process may not always be popular, the Scrum Master can facilitate it during the daily Scrum, making it a smoother experience for the team. Many agile planning tools, such as Jira or VSTS, simplify this process by automatically plotting actual and ideal trend lines for each sprint on a convenient burndown chart. When stories are grouped into sprints, the total size of the sprint is simply the sum of the story points representing the planned velocity. The team's performance in past sprints typically informs this planned velocity. Velocity is a key metric for the team's productivity, indicating the number of points they can deliver in a sprint. Over time, as the team establishes a track record of completed points, they will gain greater confidence in their ability to predict timelines. This confidence allows the API team to estimate how many sprints will be needed to complete the remaining backlog. For instance, if a team averages 20 points per 2-week sprint and has 100 points in the backlog, they can estimate that it will take approximately 5 sprints or 10 weeks to finish. However, projecting velocity can be more complex than this simple calculation. Teams improve their velocity over time as they become more cohesive and efficient. Additionally, not all items in the product backlog may be fully sized, complicating projections. This brings us to our next topic, velocity management. Scrum should never be seen as a reason to forego planning beyond the current sprint or to overlook deadlines. Maintaining a consistent team velocity hinges on stable resourcing and estimation practices. Avoid fluctuating team commitments. Don't assign people full-time to a sprint one week and part-time the next due to other projects. Keeping the team fully dedicated is essential. Scrum Masters can proactively forecast the sprints needed by gathering estimates in advance. While these estimates may not be perfect initially, they will improve with each sprint. Additionally, Scrum Masters should consider upcoming holidays, vacations, and the team's velocity trends. Are they increasing their output sprint by sprint, or have they reached a plateau? Be cautious not to fall into the waterfall trap by trying to estimate the entire backlog and forcing the team to adhere to those initial projections. Remember, Agile embraces change, and the team's understanding will evolve, leading to improved estimates. Incorporate buffers into your planning to accommodate unforeseen challenges. Ultimately, there's no better estimate than the actual performance of a completed sprint. A team's velocity is bound to fluctuate. New teams, especially those still adapting to agile processes, often experience lower velocity for the first several sprints. It's important to note that velocity isn't solely influenced by experience. Factors such as team availability, vacations, sick days, and unexpected issues like system outages can also impact performance. However, over time, many teams will notice a steady improvement in their velocity as they learn to collaborate more effectively. After several sprints, a team's velocity may stabilize as they refine their processes and eliminate inefficiencies. This provides a quantifiable measure of the team's productivity. The Scrum Master is crucial in tracking velocity and encouraging the team to analyze deviations from their expected performance. The team can identify actionable steps to enhance their velocity by understanding the reasons behind these fluctuations. Each sprint becomes an opportunity to test and implement optimizations, aiming for a net improvement in overall productivity. Let's explore one more example of velocity in action. The team has a product backlog of 56 points, and they decided to pull in 26 points at the start of the sprint. At the end of the sprint, however, the results are mixed. 3 user stories are completed, 1 is nearly finished but doesn't meet the definition of done, and another couldn't be started. The 2 incomplete stories are returned to the backlog where they are likely to be prioritized for the next sprint. Consequently, the team's velocity for this sprint is based only on the completed stories, totaling 18 points. Had the team completed all 26 points, the Scrum Master could have confidently predicted that the team would finish the remaining backlog in 1 additional sprint. However, with only 18 points completed, it seems more realistic that the team will need 2 more sprints. Given the progress made in the previous sprint, this 2-sprint projection is a reasonable estimate. Moving forward, the Scrum Master and Product Owner must decide how to adjust the team's workload for the next sprint. They can stick with the 18 points or set a target somewhere between 18 and 26 points. I hope this course has provided valuable insights into Agile API development. Thanks for watching. If you enjoyed this video and want to see more, hit the subscribe button and turn on notifications so you don't miss any updates. Please give this video a thumbs up if you found it helpful, and let me know what you think or if you have any questions in the comments. Look out for our next video explaining best practices for REST API design.